Hello everybody, this is Ted Knack and welcome to another webinar on the Extracting Value series from Certainty 3D. Today we're going to talk about a new tool and basically some new tools we've developed and their application. It's going to be looking at encroachment analysis, and we're going to take a bit of a different approach to this. I think many of you are familiar, but it's new to TopoDOT that we can do some of this. We've been able to do it in power lines for some time, but we're going to look at it in how you can apply this to design and daily operations. So that you can basically communicate that value to your customers. So we're going to look at a couple new tools, and it's encroachment, clash detection analysis, things like that. And these two examples we're going to talk about are going to show you how those can be applied to and provide value in the areas of engineering, design, and daily operations, as I mentioned. In our description, we were going to talk about power lines. Everybody knows that, and we can do that, and it's pretty common for everybody. So we kind of skipped that demo. We're going to move to some other ones that are a little more interesting and a little more out of the ordinary. But if anybody wants to know, we can do transmission line, power lines, things like that. That's not a problem. So enough being said, let's take you through it. Okay, so you know the team here, and it'll be Mally. Of course, he just basically came in one day and he said, develop these new tools while you're gone. So whenever I leave, things get done. I should leave more often. Anyway, so Mally did these cool tools, and he's going to be showing them to you today. Of course, you know Lindsay, and she's our sales manager, and she's organizing all this. And for our new attendees, Lindsay will be there to help you all the time, make sure you get what you need. Okay, so we always like to talk in these presentations. We like to talk about the value, the big picture. Why are we doing this? And encroachment and clash detection are critical in design, engineering, and ongoing operations. So the nice part about these also is they don't really require a lot of extraction or modeling. Typically, it's a classification exercise, and they return significant value and return on investment to your customers, because with these tools you can detect things that maybe clash in a real environment where you have a transportation corridor. In this case, we'll show you some rail where it might hit a tree or something like that and result in large damage, obviously. And there's a lot of, I was looking on the net before, there's a lot of papers and requirements and federal requirements for monitoring this kind of encroachment, especially along rail lines, transportation corridors of any kind. So also in the engineering and design world, we're going to see that value also, where we're going to demonstrate how we can take virtual design models of the tunnel and right away detect where it's getting too close to the road above and things like that. So we're basically you can apply these in a virtual environment and an actual environment. Okay, so the problem, encroachment along a transportation corridor. I'm sorry for this. I just thought this was really funny. Obviously, if you're you can detect the elephant, but but the bottom line is this: you have a rail corridor, and you want to know how you can imagine, how fast trees and the foliage are basically moving into that environment. This is actually a good picture here, and this is the operations level. This is what has to be done all the time. Many of you as customers are more familiar with this than we are, as opposed to your customers. You're being hired to do this kind of work along rail lines and determine if there's clash, if anything is going to encroach on the path. So this lower right picture really kind of demonstrates how every few months this foliage, these trees, branches can either grow into the path, a volume around that rail, or fall into the path after a storm or whatever. So so we kind of understand the problem. So what we're going to show you is how in TopoDOT, how you can basically use all the tools you have, and you can automatically basically define a 2D frame, so to speak, and basically move that along a path and collect all the data that intersects with that 2D custom 2D shape, which describes the boundaries of the corridor that has to be kept clear. So TopoDOT, we're going to show you that. Maddie will show you the nuts and bolts and how that works. And so that's an existing corridor. Again, this is daily operations that has to be done over and over again. So this represents a real value and a real opportunity for our customers to use our tools to basically provide value to your customer base and earn income. Okay, and the other problem is the encroachment at the design level, and this was interesting. This is kind of what we replaced the traditional transmission line one with. Here you have a design tunnel, and everybody's seen this once or twice. We show this. We like this data set a lot. But this was the Dulles Transit Corridor, and this was their design tunnel. And then they actually drove earlier LiDAR systems, done about 2008 or so. But they actually drove over and they collected all this data, this real-time data, this real data of existing conditions, and they compared it to their virtual model of their tunnel, their 3D virtual model of the tunnel. So I did a quick analysis in TopoDOT, which with tools we've long had, where we can basically click on the center line, cut a cross section, and you can see where the dimensions are getting too tight here. There's almost just a little under 3 feet. Or probably sideways, I measure wrong, but about 3 feet from where the tunnel would be, and this should have been 10 feet or so by spec. So they had to basically remove that tunnel path and adjust that. Okay, so this can be done in TopoDOT. The issue is, can you do it when you have a long path, a long corridor? You have to check it everywhere, so that can become tedious, and you can miss something. So what we've done, again, we automate that. So once again, Maddie will show you how in this environment you can take a path or a guideline down the tunnel, create your own shape, and then collect very quickly all the points that are within that area. And right away, this is flagged. These points are flagged red as being in that area, being too close to a tunnel. Okay, so this is a nice way of basically doing this in an automatic way. Okay, so I don't have a lot more to say on this. We're going to start with Maddie. You're going to turn it over to Maddie now, and he's going to talk about the virtual encroachment for design, and that's the tunnel we just saw. And then we'll move to an existing rail path, where we actually, Maddie will show you how we basically would apply that to daily operations and looking for that encroachment along the rail path. So Maddie, I'm going to turn it over to you.
All right, guys.
Okay.
So one thing I also want to point out is that this tool isn't available in your current version. It should be released in the upcoming TopoDOT version. I think we're shooting for this coming week to have that release out. So again, so you won't see it in your current toolbox. All right, and we're going to start off here with the tunnel. So I'm going to go ahead here and pull in some of this data. All right, and let's pull in this one too. Now, for this tunnel, we also have this line going down the center of the tunnel here. So what I'm going to do is I'm going to select that, and we're going to basically take or measure all of our encroachment along that center line. So I'm going to go ahead now and open up this classify by envelope along path. All right, and I'm going to come in here. I have my path selected, so I'm going to go ahead and click Get Selected for the path. And then since this is a tunnel, I'm just going to use a circular dimension, or like basically like a tube going down that path, and we're going to flag anything inside of that tube into a level we specify. So I'm going to stick it here into classification number 17, and I'm going to specify the radius that I want to classify within there. So I'm going to do about 21 feet, and that's just because you're starting from the center. And again, that's the area you're concerned with. And so if I go ahead now and click Classify, it's going to go through that data. Right now we're looking at the data by classification, so you'll see everything is white except for now this area here that has turned red. So I'm going to go ahead and hide all my classifications except for that number 17 that we just moved everything into. All right. and you'll start seeing this appear a little bit better now. Here where they're doing all the construction and such, you'll notice you can have a lot of red there just because that's not even where the tunnel's starting yet. But this particular area where they were actually a bit worried that the tunnel was coming a bit close, you can see it got flagged red. And I'll make these points a little bit thicker so they stand out a little bit better. You can see that area got flagged red. So rather than trying to go in there and take cross sections or trying to go in there and model everything, basically you pull in the data, select your center line, and then specify that area you want to look in, and it's going to flag those areas for you. And you'll notice that's the only area in that data set they got flagged. They got flagged red there.
Could you make a cross section of that, Maddie? Just
yep.
show everybody.
All right. So if I come in here, take a cross section, let's say right in here, which what Ted was showing you earlier. You'll notice this section of the road there's what got flagged red, and if let me go ahead and pull up all the data. All right, you'll see it here a little bit better too. So again, white is okay. Red is what's inside of that 21-foot radius area that I specified.
Could you draw a circle from the center there, Maddie? Maybe just show that 21 feet.
All right, 1 second. Now, my path here isn't exactly at the center. This alignment's actually offset a little bit, so it's actually somewhere right in here.
Excellent.
But let's do center. All right, we'll just do about right in there.
Yeah.
But if you look in here, our diameter should be about 42 since we put out a 21-foot radius, and that's what you're seeing there.
Yeah, I think that clearly shows what we're doing there, you know, and you see how useful that is. Okay, that's great. That's great, Maddie. I think that's pretty clear. Nice job. So let's move on.
All right. So the next one we're going to show here is going to be that that rail data set. So let me go ahead here and pull it up. All right, here we also have images for this area, so I'm going to go ahead and load in those images. All right, and let's go ahead and get our aerial image as well. All right. So for this particular area, again, I'm going to come in here, load in my data. And for these rails, a lot of times you need to go in there and see if there's going to be anything in the way of the train passing through. And in that case, you're not going to have a circular path. Maybe you'll have some sort of polygon you want to define, or just like a rectangle. And so we give you that option as well. And so once this data is loaded.
So that can be any shape, right, Maddie?
Yes, this can be any shape. So what you need to do for this is, again, select your path, and your shape needs to be basically perpendicular to that path. So as long as you have that path selected, take your cross-section by element tool. In this case, just take a cross-section anywhere you want to draw this polygon. In this case, I have one drawn here already. And you're going to want to use these tools in here. These are the only ones you'll be able to use, either this place block, place shape, or any one of these two as well. It has to be that shape element, not just like a line that you draw in there or a square that you draw in using the line tool. That's not really considered a shape element. All right. And so here I have one defined. It's going to include here the tops of the rails. You notice there's a little bit of misalignment here. You can ignore that for now. But and I also just created it in here just so you'll see it's going to come in here and pick out some of the trees and bushes we have on the side. So once we have that drawn in there, then we're going to go ahead and pull up our data again, and we'll open up that same classify by envelope along path tool. We'll come in here, select that path, and then you're going to want to select this shape here and do get selected. All right. And then we'll come in here again and change this to 17 and just click classify. All right, so if you look in here, even just at this cross-section that I had defined a sag, you'll notice those areas inside there got flagged red. I'm going to go ahead here also and just hide the white classification. All right, and you'll see this a little bit better as well. You'll notice here a lot of areas got flagged red. If I pull up the image here, you'll actually see why this is happening. Here, the rail actually starts coming up level with the road, and so basically it just quickly flagged it out. You can kind of see what's happening there. Let me take a cross section, and like I said, there you'll see it's coming close to the road surface. So all that data in there got classified as well because that's inside of that rectangle area. But so let's see. We can also come in here, march through the images. Is another way of kind of going in there and checking all this. And so if I go here in advanced images, we just look for any sort of red areas, and we can see that, you know, in this case, that tree was in the way. Let's just do view 4 here. And that's actually on the other side. Let's do. All right, so again, there's the tree there, and you can just kind of go through that rail and pick those out and see if there's anything that needs to be cut down or not. All right, so there you saw another piece of the tree way up here that's kind of hanging down, and that might need to be cut. Okay, so that's about it here with this tool. Anything, Ted, you want to mention?
No, I think so. I think everybody realizes if for some reason you didn't want the rail, you can make your box a little higher. It probably wouldn't affect anything from the ground, so that's not a big deal. But let's ask if there's any questions, and that's pretty much it. That's a great demonstration. So let's open it to questions. Anybody have any questions about that? Anybody out there, Lindsay?
No hands raised that I see.
No hands raised. Okay. Well, okay, guys. There's Todd Shuey has his hands up.
Go ahead, Todd.
Hey, Todd.
Hey, good morning. Ted, something on this class detection, I think I talked to Mauricio before on it. What we're trying to figure out is a way to use it on construction of a bridge deck, to where we go in and we scan the rebar once they place the rebar, and then bring in our pour-to grades and figure out where the rebar is high rather than them stretching string lines.
Oh, you can. Okay, so if I understand correctly, and Maddie, stop me if I'm wrong, but and Todd, you stop me. But you've got so you've got this rebar, and this rebar could be high in places. So technically, you want to put a virtual path, and you could then, in this particular essence, you can make that box around that virtual path at the right height, and then you can make that square, like Maddie showed you, that rectangle or polygon or whatever, be you know, just basically intersect anything above, so anything coming into the rebar that was poking up into that box would be detected. Is that correct?
That's correct. That's exactly what we're looking for.
Yeah, I don't see where that would be a big issue. It's be about defining the path at the right level. Do you see a problem with that? A virtual path, you know.
Yeah, that's what I'm looking for right there.
Yeah, so, yeah. I don't see. I think it's pretty similar to what Mally's done here in the rail, because, for example, he actually grabbed the he grabbed the rail, so he's actually kind of doing what you're saying. If he redefined that. Defined his block up and down, that rail would go away. So the deeper he makes that block down, the more he's going to cut it. And it's all about where the path is. So the path has to be done virtually according to design, you know, and done virtually, and represent, you know, exactly some height that the rebar wouldn't exceed. And then you know, and that path would probably be go along it would be some what do I call it, alignment or something like that, I would think.
Okay, thanks, Ted.
Yeah. Okay. Yeah, it should work out well. And does anybody else have any ideas? Great.
I see Ken Crawford has his hand up.
Okay.
Go ahead, Ken.
Yeah. Hi, folks. I was just wanting to know, Marty, when did you say that this was going to be available? Because we got actual clearance studies inside a tunnel that this could be perfect for.
This should be released next week, but if you would like, I mean, I can send you a beta. That's not a problem either. So.
Oh, okay, great. Yeah, I won't get to it till next week, so
Okay.
fantastic. Thanks.
Mm-hmm.
Okay. All right. Anybody else?
Someone asked if this would be available for vertical shafts, and yeah, it should work no matter if it's vertical, horizontal. It doesn't matter that as long as you have that path defined. Let's say down the center of that that shaft, then you can specify your shape or your radius, and it'll go through there. That's not a problem.
Okay. Okay. Okay, that's great. So anybody else? Some good feedback. Good questions. Anybody else have a question? I think Nick Salmons has his hand up. Nick.
Go ahead, Nick.
Hello, can you hear me?
Hello. After across the pond.
Yeah, pretty good, pretty good. Bit late in the day, but interesting about you're saying about the vertical shaft. We've had a couple of jobs in London on the underground system where we've needed to prove the verticality of a shaft and whether the walls are inside or outside of a given tolerance. Could you, if you've got a path defined vertically, could the tool define where the construction is inside or outside of an envelope?
When you say construction, is that existing construction, point cloud, things like that? There'd be a point cloud?
Yeah, we went into a lift shaft that had just been constructed, and the designers wanted to know if the shaft construction, the concrete, was either inside or outside of a given tolerance.
Oh, sure. Yeah, basically, I mean, yeah. I mean, it's about the path. So if you can define the virtual path, I mean, where it should be, you know, according to design, this is a line go down your shaft, and then you can make any polygonal shape you want, and it'll go through along that path and classify anything that encroaches inside of that.
Yeah, I just realised if you have two volumes, one to define the minimum dimension and one to define the maximum dimension the design would allow, then you could run it to give you the minimum. Yeah, it's all right.
Yeah, you could do that, sure. Right now you could design it twice, actually, and
yeah.
You can run it twice and classify it different.
Yeah, if I just wanted now to run it again, I just changed my shape there a little bit. Wrong.
Yeah, so if the design was either inside or outside of tolerance, you just run two shapes up and down the lift shaft to show if it bows out or creeps in. Yeah, it's all right.
Absolutely, sure. Sure. And again, they don't have to be a rectangle. You know, it can be a polygon, I guess, in whatever shape Mally mentioned before. But Mally's going to show you real quickly. Oh, you ran it again? That was fast.
Yeah.
So now he's got one classified well inside, and the red is at that other level, you know. Okay.
Yep. Cool.
All right. Okay. So any other questions? Is that it, Nick? You need anything else?
We have a question. Would Todd's solution work if the bridge deck was on a transitioning super elevated curve?
A transitioning super elevated curve. So I guess the question Mally there is, and that's kind of interesting, if I understand it correctly, you have a super elevation, so you want to keep your rectangle, you know, your rectangle is going to have to follow that elevation around, right? What do you think, Mally? I think right now it's just going to stay at the orientation it is, correct, Mally?
Yeah, your shape, I mean, you can define your shape to follow the super elevation, but it's not going to transition from, you know, like a flat road to like a super elevated curve or anything like that. It's going to stay one shape and follow that path.
Yeah, interesting concept, though. You know, it would be much more complex. So that's something, you know, I see the need for that, but right now I don't think you could do that. You couldn't do that. That would be actually a much complex, because you'd have to change your shape with your design. So that would take a little more integration between the two. So at this point, no. But something to look into. Who asked that, by the way? Who may ask?
That was Joe Fader.
Joe. Okay, Joe. Yeah, Joe, if you think it's we're always looking for a challenge, so it's not going to be, we can't be too, it can't promise you it, but I think that would be a next step for something like this. That would make sense. Any other questions?
Todd has his hand raised again, so I'm going to unmute him now. Go ahead, Todd.
Okay, here's what I'm trying to figure out, Ted. We have, and this will go right in line with what Joe's asking, we have a series of bridges. They're in curves, they're cambered, and they're super elevated. So what we're trying to do is take the DTM of the 4.2 grade, drop it down our clearance of our rebar, create that next surface, and then scan the rebar and have it give us a cut fill map above that surface.
Yeah. Hey, Maldy, I'm just thinking out loud. It's always dangerous, but we're all friends here. Let's. Do you think, Maldy, the problem with what we have now is that well, the problem, I mean, it works, but it defines one line, so you don't know how to tilt. Could you take 2 points and actually traverse 2 lines, which would actually give you a tilt as you went around the super elevation or something like that? Would that be? This is an idea, Maldy. Not signing me up for it.
Yeah. I mean, it's something we can look at if Todd or if somebody has some sample data. I mean, we can look at it, but
yeah, it's just more complex. But I see what you're saying, Todd. With the super elevation and the curve, the only way I see you doing this is you're going to have that. Does that make sense, Todd? Here's
the problem that we're running into. It takes time for those guys to stretch those strings. Get out. You got 4 or 5 guys out there. Andy came up with the idea, well, why don't we scan it and then figure out a way to tell if the rebar is high? And this is where this challenge came from. Is try to eliminate that very labor-intensive process, because a lot of the work that we're getting into, they're giving us X amount of time to get in, get it done, get it poured. And so we're trying to figure out a way to speed that process up.
Yeah. Okay. So I think what we're talking about now. I mean, I've got some ideas in the back of my head. Just if you had to get through this, if you put, if you laid lines, if they were like alignments, and you actually offset them, and they were at the right elevations, you could actually break this up into smaller pieces and smaller triangles or smaller rows, so to speak, and it would follow those with it. The 2-dimensional tilt wouldn't matter as much. Say if you did it every foot, it would probably still be faster. But I think it's something. But you would have to define where the surface of the road should be and where the rebar. Those alignments would have to be defined by you.
I have some sample data, Ted. All 4.
I think we got to look at that. Yeah, let's look at that, and let's look at that because I think it's solvable. So this is what this is for. You guys, we have a good tool here and it works. It'll work for a lot of applications, when they're very well defined right now. And of course, when they get a little more complex, like you're talking about, then we'll see what we can do. So yeah, if you can get that to us, Todd, that'd be great.
No problem.
All right. So anybody else? And no hands up. Okay. Well. Okay, so again, thank you very much for everybody attending, and thanks for the excellent feedback. It looks like this is something we'll be developing as time goes on. We can see actually the encroachment is from this conversation. It's valuable for ongoing operations, design, and engineering operations. I mean. So this is something that we're going to look into, but it's some of the value to our customers, and we have some friendly, intuitive user tools. So it's a good start, and we're looking forward to working with our customers, with you guys again. And if you have any suggestions, you can get us small data sets where this is where there's an application where this is important. Please, share with us because that's how we get the tools developed that you need. So thank you very much. And once again, I wish you guys all a good weekend. Anybody that's going out to Europe at Energia, we'll see you there. If not, of course, we'll talk to you all when we get back. And Jennifer will be here taking care of things, so you guys will not be left alone. Jennifer always takes good care of you, so don't worry about your problems and your support. We're here for you. Thank you again, and have a good weekend and a good day. Bye.